So let's talk about this keyword now. What is this keyword? Where we need to use this keyword? So let me just show you one example. First, let us identify the problem. And there is some problem when you do overloading concept. Okay. So if you overcome that particular problem, we use this keyword. Let me show you where it can be applicable. So let's take either it can be applicable is method overloading or constructor overloading, wherever it is, fine. And just again, I can take a previous example, or also I can take, let me create one more or else. So I'll name this as this keyword, main method. Okay, so here I'll just create a few class variables, let's say int a comma b. So you can also create multiple variables in the same line. Okay, this is also right. Just a moment. Okay, so now I have created two different variables. Now I'll create a method, or you can create also a constructor, that is up to you. So I'll just create a method called void add. This will take two parameters, int, some called x, some called y, and here x will be assigned to the a, and then y is assigned to the b. Okay, this is my method. And I'll also create or else I'll just give some different name, get values. Okay, and this will get x and y and I'll assign to a and b. Now I'll create one more method here. I'll say void print values. I'll create one more method called print values. So what this method will do is this method will print the values of a and b. So here I will print system dot out dot print ln. I'll just print value of a, and system dot out dot print ln. I'll just print value of b. So these are the two methods I have. And if you want to call these two methods, I need to create an object in the class. If it is a constructor, we don't require. So I'll just create an object for this class, this keyword. I'll just say th is an object name is equal to new this keyword. Fine. So now I will call the first method get values. Okay, th dot get values. So we need to pass two parameters, right? So I'll say 10 comma 20 I'm passing, and then 10 is assigned to the x and again reassigned to the a. 20 will be assigned to the y and reassigned to the b here. And these x and y called as a method variables. Okay, and Preeti is asking a question, can we ask for the values from user at the runtime? Yes, we can still ask, Preeti, but I haven't introduced that concept so far. We need to use a scanner class, we need to create one more object. There is a process to accept input from the user. Okay, we need to write multiple statements here. So that is the reason I haven't told you. Okay, I'll just show you in today's session or tomorrow's session. Okay, that's very simple one, but that is not much easy like C++. In C++, we have a scanf or printf statement, right? So it is with single statement we can get the input from the user there, but here we need to write multiple statements. Okay, so that's the reason I'm just passing it. We can still take the input from the user. Fine. So here 10 comma 20 will be assigned to the x and y, and since over here print values will be print those values of a and b. Now I'll call th dot print values. Okay, this is the method. Now when I run this code, what is an output we will expect? So when I run this code, I will expect 10 comma 20. So this is our expected output. Fine. Now what I will do is, if you observe here, so a, b are called as instance variables. Okay, or class variables. We can call them as an instance variable or class variables. And here we are using different variables, right? X and Y are the different variables. So these are all called method variables. These are called a method variable or external variables. Okay. So here the question is, We have A and B internally as a class name or class variables. And here, instead of using different variable names, can we use the same variables name here? Can anyone guess? Can we use the same names here? So here, I'm just giving the different names, X and Y. So why should I give the different names? Can we give the same names here? Yes, we can still give the same names here. A and B. Okay, so A and B have given. So now if I give A and B, what should we do now? This A should be assigned to the class variable and this B should be assigned to the class variable B. So here I will just replace A and B. Okay, so is it correct? Can anyone guess? So I have just used the same variable names here. And now here class variable names and method variable names also same I have used. And again internally, normally whatever variables we get here will reassign to the class variables. I have done the same thing here. Okay, so here, normally we know about these two are the class variables, A and B. And whichever variables we defined within this class, within the method as a parameters, they are called as a method variables or external variables. Okay, outside of this method, whichever variable is created, there comes under the class variables or instance variables. Okay, now this program is syntactically correct. There is no issue in this, but it is not correct logically. So when I run this code, observe this, what it is returning. It's written 0 and 0. It's not giving us as per our expected, right? So why it is giving 0 and 0? Why? Because here we are using same variable names a comma b, but here we can still use it, no problem in this. But here at the time of assignment, what method is doing is the method is doesn't know about this. What is a is equal to a? I'm saying, right? So a is equal to a means which a is belongs to class, which a is belongs to method variable. It cannot differentiate by this method. Okay, this method is not able to differentiate which A is belongs to class, which A is belongs to method, and which B is belongs to class, which B is belongs to method. So basically, this method is not able to differentiate them. So that is the reason it is giving the default values are 0. Okay, this is the problem in this. But still, I want to use the same variable names. I don't want to go for different names, but still I want to achieve my task. So how we can do that? So simply just say using this keyword. Here just use this keyword. This dot A equal to A. This dot B equal to B. So what this will represents? This is represents. This will say, okay, this A is belongs to class, and this B is belongs to class. So this keyword is representing that particular variable or belong that particular variable or variables or belongs to that particular class. Okay, now this keyword is representing, this keyword is differentiating. So now the class or method will know about which variable is belongs to method, which variable is belongs to class. Okay, now we'll run this code, you will get exact output. So this is how we need to use this keyword. So when we need to go and use this keyword, if you want to still if you want to use the method variables names exactly same as a variable names, then you can differentiate them by using this keyword. Okay, so Urvashi is asking question, so why can't we just use separate variables? You can still use separate variables, but as I said earlier, every variable will occupy certain amount of memory. Okay, every variable is occupying certain amount of memory. So whenever you're creating a programs or if you do some programming, we should avoid a number of variables. Okay, we should always avoid number of variables. So we always make sure a minimum number of variables we must use always. We always trying to reduce the number of variables. Okay, so just like array, so yesterday we have discussed about array concept, right? So if you want to declare 10 variables, 10 numbers, I should create 10 variable names like this, a b c d so on, right? So instead of creating these number of variables, I can just create a one array which contains all the values. So how this we used to reduce? it creates only one memory location. But if I create more number of variables, the maintenance is very tough, and also it will occupy a lot of memory space. So that is the reason we need to always prefer to reduce the number of variables. So that is the reason we have to use like this. And Preeti is asking question, this points to class variables, or yes, whenever this keyword is used, that particular variable is always points to class variables. Okay, so that's the usage of this keyword. So whenever you want to use method variables exactly the same as a class variables, then if you want to differentiate them, method variable and class variable, if you want to differentiate them, you must use this keyword. So this dot a means this a variable is belongs to class, and this dot b means this b is belongs to class, and other a and b all belongs to method. Okay, so Preeti, is it clear now? Fine. So this is all about this keyword, and this keyword can be used in constructor also. So instead of method, if I create a constructor, so there also you can use the same variable names here. And but internally, how we can differentiate this method variables and class variables by using this keyword. Okay, this is same concept again applicable for constructor also. So remember this, very important, and this keyword can be used like that. Now let's go for the last concept, static variables and static methods. This is very important for us. Static variables and static methods. So far we are using main method as a static, but exactly we don't know what is static and right. So now we are going to discuss this. What is static and static methods? So let me just give you a small use case where the static will be applicable. So let me just share a small presentation. Okay, so static is a keyword, can be applicable for method and also variables. Okay, static keyword can be applicable for variables and methods. So we can create static variables and we can create static methods. But what is an advantage of it? Where we need to use static? So what is exactly use case? So let me just show you the context here. So observe this picture. So I have a small class called as employee class here, which contains a few variables called emp number, ename, department number, and there is also a method called as a bonus. So employees class contains these variables and a method. Now I have created multiple objects for the same class. So here emp1 is one object, emp2 is another object, emp3 is also another object. So as soon as I created object, it will get its own copy of variables and methods. So now if you observe this emp1 is having emp number, ename, department number and bonus, and emp2 also having its own variables and method, and emp3 is also having its own variables and methods. Okay, and this is a context, basic concept we have understood already. So there is a scenario, for example. Okay, this is just like a scenario. Okay, it's not always applicable, static will not applicable always. Okay, and some scenarios I'm going to show you one use case here. Okay, in this use case, suppose let us assume these three objects or these three employees are belongs to same department number. So these three employees are belongs to same department number. Let us say department number is 10. So all three employees, for each employee I have created different object. So all three employees are belongs to same department number, that is 10. So in this case, what happens is we need to assign the values for every variable, right? So this is common thing. So when I create an object emp1, I will assign some values to these variables. Emp number is 101, name is John, department number is 10, bonus method I will call, and emp number 102, ename, department number and bonus, and emp2 3 also I need to define the values. So emp number, ename, department number and bonus. So each individual object we need to assign values of those variables. Okay, till now it is fine. But here the problem is, suppose any variable, let's say department number, is same for every object. Okay, department number is same for every object. So when I assign the values like this, in EMP1 I have assigned department number 10. EMP2 also I have assigned department number 10. EMP3 also I have assigned department number 10. So suppose if I create 100 objects like this in 100 places, I need to assign this value. So if I do this approach, there are two problems. Okay, if I do this approach, there are two problems. But other variables are fine because other values are different. Here this is 101, this is 102, this is 103. And name is also different and bonus is different. But when this is applicable, if the value is same for that particular variable for every object, then the problem. So there are two issues here. The one issue is, as I said, whenever we create an object, it will occupy certain amount of memory. Like EMP1 memory is different, EMP2 memory is different, EMP3 memory is different. Again, each individual variable is also occupies certain amount of memory. So here EMP number will get some memory, E name, DPT number, bonus, each and every variable and the value will occupy certain amount of memory in your system. So like this. So if I create this in this approach, as I said, every object is occupying memory, so that every variable is also occupying some certain amount of memory. If I have 100 objects like this, okay, and if I assign this variable 100 times, so how much space it will occupy? Lot of space is occupied. Okay, lot of space is wasted because every object here, DA number 10 required a memory. Let's say here occupied 2 KB of space, and here it is also occupied 2 KB of space. Here also it is occupied 2 KB of space. So if you count like this, it will be finally lot of memory will be occupied. This is the first problem. The second problem, suppose tomorrow all these employees are moved to some other department number. Okay, all these employees are moved to some other department number. And in that case, what I should do now? Again, I should change this value in each and every object. So suppose it becomes 20 now. So I need to go and change here 20, 20, 20, 20, so on. All 100 objects I need to change it here. So these are the two different problems. These are the two different problems. One is it will occupy the lot of memory. The second thing is, if I change, suppose tomorrow if any changes happens, then that change should affect in all other objects. But we need to go and modify each and every object. So that is a problem. So to overcome these two problems, the static will come into the picture. So what are the two problems? Every object occupies certain amount of space in the memory, so that every variable is also occupy the memory. That's the one problem. Second is objects are independent. So these objects are completely independent. There is nowhere related. So if I modify the variable value object 1 here, that suppose if I suppose it becomes 20 now, here I modified as a 20, that will not affect on other objects because every object is independent. So we need to go and modify this value in every object. So that is another problem we have. So how we can overcome these two problems? By using static. Now let us see this scenario. So what is that variable which is common for all the objects? Department number, right? So instead of assigning this department number 10 in each and every object, what I will do is I will just assign the value here itself. Okay, I'll make that variable as a static. Now what happens? So in the class level itself, the class level, when I creating a variable, I will directly assign the value here 10, and then I will make that variable as a static. So when I say that variable as a static, it will create a separate memory location, and here the dbit number 10 will be stored. This is a shared memory. This is called as a shared location. As soon as I make a static variable, this will create a separate memory location. There department number 10 will be stored. Now, so let's create three different objects now, EMP1, EMP2 and EMP3. Now EMP1 is created, it's getting its own copy of variables and method, right? So EMP number is assigned 101, E name and bonus also we have assigned. But what about DEPT number? The same DEPT number will be applicable for this object EMP1. Okay, if still you want to change, you can change it later, but this DEPT number 10 will be applicable to EMP1. And if I create EMP2, the same DPT number 10 will be applicable to EMP2 and the same again applicable for EMP3 also. So what does it mean is every object will share the same department number 10. So this department number 10, this is only one memory space. Here let's say it's a 2 KB it is taking, but here again it will not occupy the memory. So, but previous example here 2 KB, 2 KB, 2 KB, and so on it's going. But this time, as soon as I make it as a static, this creates a separate memory location. There, the static keyword will be stored. Okay, now this variable is shared across all the objects. As soon as you created this object, this DPT number 10 will be applicable for EMP1, EMP2, EMP3, and so on. Or this is your shared memory. Okay, so this one will solve one problem. What is that problem? It saves the memory. It saves the memory because here we are not assigning the value to department number. In each and every object, we are not assigning the value. But here at the class level, we just say static. It creates a new memory, and here that variable and value will be stored, and the same variable and value will be shared across all the objects. Now, this is a common variable for all the objects. All the objects are shared this variable. That's the first problem. So first problem is solved. It saved memory. Now the second problem. Suppose the DPT number is changed. Suppose these employees are moved to some other department number called 20. Now just change in the class level itself. And Naveen is asking question, does that mean we have to use static variable in all the methods in class, yes. So static is a one-time keyword, Navina. So if I say a variable as a static, that becomes a static. It creates a separate memory. Suppose if you still want to use this variable, yeah, in this class, yes, in this class you can still use this variable just like other variables. Okay, okay. Just for wait for a few minutes because I haven't completed this. So once I have completed this complete static, then you can ask your questions. Okay, because whatever questions you are asking you is I'm going to cover them in few minutes. Okay, let's complete this once we have get the complete picture, and then if you have still have any questions you can ask me now. So just I'm in the middle of this. Okay, so we have discussed about two issues. One is a memory issue because if I initiate that variable in each and every object, that will create the memory. But when I say a variable as a static, this create a different location, and every object is shared this particular variable. Okay, this becomes a shared location. Now that will solve the memory issue. The second issue is suppose tomorrow these employees have changed the department, moved to some other department. Now what I can do is we can do two things. One is we can change this value at the class level. Okay, just modify this value at the class level. That will automatically affect change here. So every object will be affected. Every object is affected. So we no need to go and change in every object. That is not at all required. Okay, that's the one way of updating. The second way is suppose if you don't want to update here, so you can update that value by using any one of these objects. Suppose here EMP1 dot department and 20 have modified here. That will automatically affect other objects also. Here becomes 20, here it is also become 20. Why? Because this is a shared variable. So if I change here, that will automatically affect here. If I change in the class level also, it will affect here. So even we can also modify this value by using EMP2, by using EMP3, and by using any one of these objects. Or you can directly modify in the class, that will automatically affect here. Because this is a common variable or shared variable across the class and all the objects. Even though objects are independent, they are nowhere related, but the static variable and static methods are common across all the objects. Okay, so guys, are you clear now how to use this static keyword? So there are two advantages when you use static. So when I say variable or method also we can define as a static. So when I say variable or method as a static, that will create a separate location and that will become a shared variable or shared method across all the objects. It will solve two problems. We no need to assign this value in each and every object. Second problem, suppose tomorrow the values change, we can just change here itself. Automatically all the objects will be affected. by this value, or we can change this value by using any one of these objects that will automatically affect in other objects also. So this is a concept of static. Internally, the static will works like that. So this is a use case where the static will applicable. We should not use static in always, okay? Wherever it is required, so there and all, we have to declare a variable or method as a static. Okay, so the concept is clear, everyone. Please confirm. I'll show you one example on this. So where we need to use static and how to use this. Okay, but if I create a variable or method as a static, so we have certain access level limits. Okay, let me show you how we can access these static variables and all. So let's go to the program. So I will create another class to demonstrate a static keyword. So please focus on this. I'll name it as a static example. Static example. Let's take a main method. Okay. So can anyone tell main is a static method or non-static method? Main is a static method or non-static method? Can anyone guess? Yes, main is a static method because we have a static keyword here, right? So anything. So if variable or method, if it mentioned as a static keyword, that will be considered as a static methods and static variables. Okay, if it is a variable, that is called a static variable. If I say static for method, that method is a static method. If I don't specify static, those methods and variables are considered as a non-static variables or non-static methods. Okay, so here uh, two things we need to discuss. Okay, static variables and static methods. Static variables and static methods. So I'm going to show you three important points here. So within the class, we can have static variables and static methods, and non-static variables and non-static methods. That is up to you, whichever you want this define. Okay. So what I can do is I'll just mention three important points here. And before that, let me just create a few methods and variables. Here, I'll create a variable called int a is equal to 10. So this is a normal variable. I make this as a static variable. Okay, now it becomes a static variable. As soon as I say static, it changes to italic. And this is your static variable. Static variable. Now I'll get one more variable, int b equal to, I'll say 20. I don't specify static keyword for this, so this is non-static variable. Non-static variable. One is static variable, the other one is non-static variable. And similarly, I will also create one static method, the other one is non-static method. So if I create a method void, let's say m1, this is a method, and here I will write some message system.out.println, and I will make this as a static. Okay, so then this method becomes a static method. This is a static method. So here I'll just write some message. This is a m1 static method. Okay, some message I have given. So this is your static method. Now I will also create one more method called non-static method. So let's say void m2. Okay, so this is non-static. Non-static. So inside this method I will write system.out.println, and this is m2, which is non-static method. Non-static method. Okay. So let's finish this in double quotations. Fine. So now I have created two variables. One is static variable, the other one is non-static variable. And similarly, I created two different methods. One is static method, the other one is non-static methods. Okay. Now, main is also static method. Okay. Everything will start from the main method, right? So keep this main method one. So I'll tell you few points here. Just remember, very important. The first point is I will talk about static methods first. Okay, static methods can access only static stuff. Okay, remember this point. Static methods can access only static stuff. Means static variables and static methods. So this is a direct access. Directly. It's directly. What does that mean is, so static methods can access only static stuff. Only static stuff. It cannot access any other non-static stuff. So static methods are always access only static stuff, and this is a direct access. What is direct access? Without creating any object. Even we don't need to create any object. We can still access those variables and methods. So let me show you. So static variables or static methods can access only static stuff. Okay, just remember this point. Come back to your program. So main is a static method, right? So I will tell you now. Static methods can access only static stuff. So main is a static method. Now I am trying to access static variable and static method from the main method. That's the first point. So static methods can access only static stuff. So let us see whether it is able to access or not. So main is a static method. So A is a static variable. M1 is also static method. So let us see, can we access them directly or not without creating any object. Okay, that's the main meaning of direct. So here direct I'm accessing. So how we can access? I'll just say system dot out dot println. Okay, just I will print the value of A. That's it. So here I haven't created any object. Observe this. So did we create any object here? No. Directly I am accessing this variable here. Okay, now it prints direct value here. So prints value of 10. Because without creating any object, I am directly able to access this A. Similarly, I can also directly call this M1 because this is also static. Main is also static, variable is also static, this M1 is also static. So directly we can call M1 like this. So we don't need to create any object. So when I run this, it will also call M1 method. So this is an output for M1 method. So what we understood based on this is static methods can access static variables, static methods directly. This is a direct access. But we cannot access non-static stuff. So main is a static method and B is a non-static variable. This is a non-static variable and M2 is a non-static variable. So let's try. So if you want to print B value, okay, it's giving an error. So why it is giving an error? If I put here, it is saying cannot make a static reference to the non-static field B. So what does it saying is main is a static method so that you can access only static variables. You cannot access non-static. So if you still want to access, change this as a static. Change B as a static. So this is a suggestion it is giving. So this statement is incorrect. Incorrect. So why? Because B is non-static variable. B is a non-static variable. Similarly, if I try to call M2 directly, it's giving the same error again. So change M2 to static. So M2 is a non-static so that I am not able to access directly. So this is also incorrect. This is also incorrect because M2 is non-static method. Okay. So as per the first point, static methods can access only static stuff. This is a direct access. We cannot access non-static stuff. We can access only static stuff. So directly means without creating an object. Without creating an object. That's the meaning of direct access. Okay. Fine. So suppose this main method is present in some other class. This method is present in some other class. But can we call like this directly? Still we can call directly, but just we need to specify the class name. So class name dot a, class name dot method. So we can directly specify the class name and then we can use it. So what is the difference? If you have main method within the same class, we can directly access even with, we don't need to specify the class name. But suppose this main method is present in some other class, then you can still access this variable and method, but we need to specify the class name. But then also you don't need to create an object. Still that is a direct access. So static variables and static methods we can directly access by using class. We don't require an object. Okay, but in this context, in the first point, so when you're trying to access static variables and static method from the static methods, you can directly access without creating an object. So this is the first point. So static methods can access static stuff directly without creating any object. So guys, are you clear this point? So please confirm on the chat window, then I'll move on to the next point. So you have to be very clear on this. Okay, this is the first point. So static methods can access static stuff directly. It cannot access non-static stuff. I show you both the ways, right? Now, second point. In the second point, what I'm saying is static methods can also access static stuff, but through object it is possible. Through object. This is the second point. In the first point is completely contradictory statement. In the second point, right? What in the first point I'm saying, static methods can access only static stuff without creating any object, direct access. But in the second point, what I'm saying is static methods can also access static stuff. But how it is possible? Through object it is possible. Here we must create an object. Okay, so static method can also access static stuff, but through object it is possible. Through object it is possible. So let us see how this point will work. Through object it is possible. This is the second point. Here I am writing. So static methods can also access static stuff, but through object it is possible. So now I'm trying to access this. Main is a non-static method. Sorry, main is a static method. Now I am trying to access non-static. So what are the non-static we have here? B is a non-static variable. M2 is also non-static method. So if you want to access them directly, it's giving an error. We already tried it, right? If I try to access them directly, it's giving an error. Now I will try to access them through object. So now we need to create an object for this class. Static example SE is equal to new static example. Now through this object we can access. Now SE dot A, sorry, SE dot B, I can print this value system dot out dot println. Now we are able to access this through object, and I will also call SE dot M. Okay, so now what I have done is static methods can also access static stuff, but through object. Sorry guys. So I'm trying to, static methods can also access static stuff. Sorry, this is not static. Okay, not static. So I have mistaken here. Static methods can also access non-static stuff. Remember this. The first point, static methods can access only static stuff, that is direct, without creating an object. And second point, I'm saying static method can also access non-static. Static method can also access non-static, but through object it is possible. So here initially I have tried accessing non-static, but it is not possible directly. Now I have created this object, and through this object I am calling non-static, that is M2. So first one is B, right? B is a variable. So I'm trying to access this. System dot out dot println SE dot B. So now this is a non-static variable. This is non-static variable I have accessed through object. Through object. Okay, and similarly I will also access non-static method, that is M2. Okay, so see this. What is the difference here? But here we are not able to access non-static stuff directly, but here we are able to access them through object. Okay, now let's run this code. Now you can see that these two are outputs of these two statements. Now these last two are the outputs of these two statements. Okay, this is correct now. So here again we are accessing non-static method, okay, through object. Okay, that's about second point. Again I'll repeat second point. Static methods can also access non-static stuff, but through object only it is possible. This is not direct access. Okay, so guys, are you clear now? First and second points. If there is any confusion, please ask me now in first and second points. Okay, so static methods, we have certain restrictions to access other methods. So these are the two restrictions. So static methods can access only static stuff by default without creating any object. That is direct access. But if you still want to access non-static stuff in static methods, we must access them through object. Okay. Now I'll tell you third point. So in the first 2 points, I talked about static methods. But what about non-static methods? So non-static methods, we don't have any restrictions. So non-static methods can access both static and non-static stuff directly without creating any object. So non-static methods, we don't have any restrictions. So non-static method can also access static, non-static, everything without creating any objects. Okay, we don't have any restrictions. Now let me show you. So main is a static method. We have already done this. Keep one side. Now, so M1 is static, M2 is a non-static. So along with this, I will also create one more method which is non-static. Let's say M3. Okay. So what is the third point I'm saying is non-static methods can access both static and non-static stuff directly. So no object are required. Now in the M3 method, I will try to access these variables. Okay. I'll just say system.out.println A. Now this is a direct access, and also I'll just access B. Now you can see there is no difference here. So this is a static variable, this is a non-static variable. Both I can access directly from non-static method. Similarly, I can also call static method, non-static method directly. So here I will call M1 and here I'll call M2. So there are no restrictions for non-static methods to accessing other methods, but only the restrictions are there for only static methods. Now M3 is created. So how again M3 will call? Until unless we call this M3 method, these will not be executed. These statements will not be executed. So how to call M3 method now? M3 is a non-static method. So how to call M3 method? Again we need to execute this M3 method from the main method through object. Because M3 is a non-static, main is a static. So here we need to use sc.m3. And then M3 will be called, and internally M3 will print a static variable value, non-static variable value, and internally it will execute static and non-static methods. Okay. So here I will also write a message system.out.println. Okay, this is M3 method non-static. Okay, fine. So non-static methods can access both static and non-static stuff directly without creating any objects. We don't have any restrictions for non-static methods. Now run this code. Now see here. So here M3 method is called. This is M3 method, right? So this is an output we are getting. So this is the output we are getting. Now you can see it prints A value 10, B value 20, and M1, M2 again called. So M1, M2 called means this is giving to these two outputs from M1 and M2. Okay. So non-static methods doesn't have any restrictions. So these are all three thumb rules you have to remember whenever you work with the static variables and static methods. So I'll just summarize this, and Preeti is asking question. If static void m1 wants to access int b, which is non-static, how it will access? Okay, let me show you. So what you are accessing, if static void m1, so you're talking about m1. Okay, so this is a static method, wants to access int b. So int b is a non-static. Okay, and how it will access? Yes, we can still access. So m1 is a static method, b is a non-static method. So what is the rule for this? Can static method access non-static variable by default directly? No, it's not access. But how we can access? Through object we should access. Through object we can access. But how to create an object here? So we have to create a static example. SE equal to new static example, and then SE dot we can access B like this. So here we can print this value, system dot out dot print. So this is how we need to access. So anywhere the same thing. So anywhere the process is same. Okay. So here if you want, M1 is a non-static method and B is a non-static. So if you want to still access, we must access through an object. Okay, this is possible now. So let's run this. It's give you an output here. But again, this M1 method should be called from the main method. So then only this piece of code will be executed. Okay. So here M1 called, so not here. So here M1 is called static example M1. First time it is giving here. And when I go here M1, okay, so again it is created object for SE. So it is print SE.B. So B value is printed here. And this is M1 static method. So here this is a method. So static method M1. Let me just recap it here. So here we call M1 method static method. From non-static, it will go here. So these are the statements it's created. So internally it creates this SE object. Okay. Now it prints the B value of SE and then it gives this message. This is M1 is a static method. So this is an output for this. And then it will exit. Again, it will go and execute the M2. Okay. So everywhere the concept is same. So if you remember these two rules, the same rules can be applied everywhere. But remember, one more important thing is every time when you create some objects, always you need to create in the main method. Okay, this is not a right approach. So syntactically everything is fine. This is correct. I'm not saying it is wrong, but this is not a best practice. Okay, so because always objects will be created from the main method, not from the normal method. Okay, remember this point. So is it clear everyone? So I'm just summarizing these points again. So just see this table. It gives you the clear picture. And static methods can access static variables and static methods directly. So this is the direct access. This one and this one. This one and this is direct access. And static methods can access non-static stuff. Yes, but through object. So here we need to use object here and here. This is the first line. And non-static methods can access static methods, non-static methods directly. So there is no restriction. This is the direct access. So remember this table and then it will be very easy for you. Okay, so that's all about static variables and static methods. So going forward, I'm going to use this static keyword very frequently. And if I say static, those variables can be directly accessed from static methods. That is main method. Okay. So any questions, anyone? So that's all for today here. I'll just stop it here. If you still have any questions, you can ask me. And come to the assignment. Okay, one more thing is pending. I'm just take another 2 to 3 minutes. It's very simple. So far we have used system.out.println, right? So what is this? Need to understand. What is system.out.println? This is the right time to discuss about this method. Because we already know about classes, objects, static keyword, right? So this is the right time to understand. System.out.println. Let's understand this one. System.out.println. This is again depends on static. Okay. So You guys should tell this. Okay, I'll just give one example. So before discussing this system.out.println, I'll give you a small scenario here. Observe this. I have a class called as a test. This is my class. So in this class I have a string variable. Let's say string, okay, s is equal to, I have assigned some value to this. Okay, this is my a string variable which is created in the class, and this is a static variable. This is a static variable. Okay, this is my class. Test is my class. I have a variable called s. The type of s is string, and it is also static variable, and I have also some value inside it. Okay, this is a structure. Now if I want to access this variable from outside, and also I want to find length of a string. First I want to access this variable from outside of this class, and then I want to find length of a string. So how to do this? So I want to access this variable now. How to access this variable? This is a static variable. Can anyone guess how to access this variable called s? So this is a static variable. So how to access the static variables? How to access the static variables? By using class name, right? So we don't need to create anything. So just we need to access this variable by using class name. So how we can write now? How we can write? So can anyone suggest? If you want to access this variable, okay, how to write the statement? Yes, class name dot variable name. Because this is a static variable, we can directly access by using a class. Now, so s is contains already a value. So I want to find out the length of this string. So how to find out? Followed by your s is a string variable, so that I can apply all the string methods. So I will just say length method. Length method. So what this will give you now? So test is a class. S is a string variable of type is static, which contains a value, and length is a method which will find out length of this particular string. So why we have applied this method here? Because string is s is a string variable, so we can apply all the string methods on string variables. So that's the reason I have applied length method. So this is a whole statement. In this statement, test is a class, s is a variable of type is string and static, and length is a method, string method. Okay, so this will give you 7 as an output. It returns something, that's a 7. Now let us simulate the same thing for system.out.println. Okay, now in Java there is a predefined class called as a system. In Java there is a predefined class called as a system. So in this class there is a variable called out. Out is a variable. What is the type of this variable? Print stream. Here the s is a string type, but here out is a print stream type. So this is also predefined type. So here s is a string type. Similarly here out is a print stream type, and this is also a static variable. This is also a static variable. So this is the context. So in Java there is a class called system, predefined class, and inside this there is a variable called as out. This type is print stream, and this is a static variable. Now here when I say variable as a string, I am applying all the string methods here. Similarly, if this variable is a print stream is also having certain methods like print, println. All the methods are belongs to this print stream. Just like length method is belongs to string, right? Similarly, println methods are belongs to print string. Okay. Now you guys should tell how to access this out variable. Okay, so Justin Raj is asking question. I was thinking system is a namespace like in C#. No, it is a predefined class in Java. Okay. Okay, so now how we can access this out variable now? First, class name system dot out is a variable. Now, so as I said earlier in the above example, I can apply all the string methods on top of variable s, right? Similarly, I can apply all the methods which are belongs to print string. So dot println is a one of the method is available which is belongs to this print stream class. So what this println will do is whatever we added in this double quotation as a parameter, that will be printed as an output in your console window. That's the functionality of println. But here length is not printing anything. Length is returning some value. So as I said earlier, the methods may return some value or may not return some value. That is up to our requirement. But here length is returning some value, but here println not returning anything. It is just printing some value whichever we are providing inside the double quotations. Okay, this is the function of println. Now if you observe the whole statement, system is a class, out is a variable of print stream and static type, and println is a method which is belongs to print stream, and whatever message you have given here, that will be printed as an output. That is done by the println statement, println method. Okay, so this is the context of system.out.println. So if in interview, if anybody asks you, you should explain with this example. Okay, so guys, are you clear now? Why is system.out.println? So what is system, what is out, what is println? Okay, not only println, we have also another method called print. Okay, println will print these messages in one by one, so in the next lines, but print will give you message in the same line, will print output in the same line. So that's the difference. Okay, so this is all about system.out.println. So that's all for today.